This is what I mentioned earlier about Monte Carlo for parallel analysis. I think we will skip this part. Okay? We will skip this part. If you really want to learn how to do this, you can actually look for YouTube video how to do this. But later on, what I can do is I can upload the application installer. Okay, so this is actually the better way to decide how many factors you actually have in your data. Okay. Oops. Okay. Okay. Right. This is Monte Carlo parallel analysis. Okay. This is where you decide that based on this analysis, you have four factors. Okay. Okay. Sample size needed. It depends on your factor loading. Again, this is only a general rule of thumb. Okay. If your factor loading is 0.50, sample size 120. If your factor loading is lower, 0.40, you should have more than 200. And that is why you may come across some articles which tell you that to run factor analysis, to run EFA, you need a sample size of 200 and above. Okay, this is the reason. When you explore something, you can allow your factor loading to be slightly lower. Okay. In general, we prefer this 0.50. In general. Okay. We are talking about EFA, exploratory factor analysis. In general, we prefer this. But you can go as low as this. Okay. But if you go as low as this, you must make sure your sample size is bigger. Okay. These two I will not recommend. Okay. For me, this is too low. Okay. So for EFA, the lowest would be this one. Okay. Some people may disagree with me. It's okay. A healthy argument is perfectly fine. Okay. Because my concern is this suggests there are problems with your data. Okay. That is why, for me, sometimes I cannot trust the number 100%. I better go back and check using qualitative method, using other method to check. Maybe there is other issue. That is why the software is telling me this is the result. I don't take it on face value. I better go back, step backward to find out what is actually the cause. Okay, 0.5 normally accepted. This Saturday and next week, you will see why when we do confirmatory factor analysis, CFA, not EFA, confirmatory factor analysis, we always like to look at this one, 0.7. Okay. For confirmatory factor analysis, we can go as low as this one, but we prefer this one. Okay, we prefer this one. I will explain to you on Saturday. Okay, how to do the why statistically this is the case. Right? Again, you have the references and you have the rating. For me, this is not necessarily usable because also it depends on many situations. If you look at the citation, these are from psychology. So if your study is marketing, if your study is tourism, event tourism, hospitality, you can always refer to the articles in your field to decide what are the acceptable factor loadings. Alright? So you don't really have to follow this. You can follow this, as a general guideline. Okay, if this is relevant to you, you can use this. Okay, you can use this. At least you have something to show. Okay, this is the result we will look at later. I will skip this. Alright? Alright, so let's look at factor analysis. Enough story for me. So where is it? This one? Oops. Oh. Now, can you see this? Factor analysis, I move to the right, to the left, to the right, to the left, right, left, right, left, feel? Did you see factor analysis?
Yes.
Okay, right, left, right. Okay. Alright, let's look at this one. Okay, remember, quick analyze. Quick analyze. I better do it again, just in case you are lost. Okay, analyze, dimension reduction, and factor. Right? Click factor. Once you click factor, you will see this. Okay? Alright? Alright, by the way, you can drag this box and make it bigger. Alright? Now, in your data set, I purposely put F1 to Fn1 and Fn10. Now, Fn here stands for food neophobia. Food neophobia, meaning people's reluctance to try food which they are unfamiliar with. Okay, people's reluctance to try food which they are unfamiliar with. Now, let me show you what these items are. Again, you need to briefly know the context of the study. Okay, can you see all this?
Yes.
Okay, I'm not constantly circling new and different food. I don't trust new food. If I don't know what is in the food, I won't try it. I don't like foods from different countries. New food looks too weird to me. At dinner parties, I will not try a new food. I'm afraid to eat I'm afraid to eat things I've never had before. I'm very particular about foods I will eat. I will not eat almost anything. I don't like to try new food restaurants. Okay? Now, these are the 10 items you have for FN. In your research, if this is the case, in your research, remember what I said earlier, you can use EFA to find factor structure. So what it does is, these 10 items will go into different factors. How many factors? We don't know. SPSS factor analysis will tell us. How will they tell us? They will tell us based on data correlation. Okay, this is the first thing you must know. Also, remember what I said just now. If this is your research, you get these 10 items from past studies. Food neophobia is something that you adopt for your study. And these items are something which you adapted from past studies. You revise a little, okay, because your study is about ethnic food. If this is the case, you have a theory to support. You have strong literature to support. Food neophobia has been tested before. If this is the case, you can decide to ignore EFA. Don't do EFA. Just go straight to regression. Just go straight to smart theories. Alright? Because if you run EFA, the danger is the factor structure that EFA produces may be different from what the theory says. Because EFA does not know theory. EFA only knows factor structure based on your data correlation. And the issue is, what if your data is not so good? Okay, so SPSS, EFA will not produce something similar to what the theory says. It may not produce something similar to what past studies say. It will only produce what it says it is based on your data characteristics. Okay? Either you are happy about it because you see wonderful story, or you are very unhappy about it because you are stuck. Okay? Factor analysis gives you the results which do not make sense. It contradicts past studies. There is no theory to support. You don't know why this is happening. Okay, SPSS also does not know why. SPSS will only tell you because your data tells me so. Okay, it works based on correlation. All right. So remember, if this is your study, you may not have to do EFA. Okay, but later on when we look into the result, remember the two things. Number one, I want to show you how to check data validity. Number two, even though not useful, but it's also good to learn how we run EFA to get the results. And the results are factor structure of your data. Factor structure. Alright? Okay, let's click and let's run analysis. Okay. Let me show you. Okay, this is, okay, again, I hope you see this. So let's put FN1, FN10 here. Okay? FN1, FN10 here. Okay? Why don't you put all this in? Why don't you put all this in? Okay? Again, remember what I said earlier? Because you already know the factor structure of these items. Okay? These items belong to ATT. You already know the factor. These items belong to SN. You already know the factor. You already know the factor structure of this. You don't have to mix them up and put it here to let the software decide. You don't have to do that. Okay? If you don't believe me, if you cannot visualize what I said just now, what you can do is you purposely put all this into this. Maybe I can demonstrate later. And let's see if the result of EFA is similar to what we have already known. Okay? You may see this goes here, this goes here, this one goes there, this one goes there. Why? Because EFA does not know literature. EFA does not know theory. It only knows data correlation. Okay, that is why in many cases you don't have to use EFA, because you already know the factor structure. How do you know? Because it is based on theory, because it is based on scale developed by someone, and it has been tested by many authors. It is published in papers, and that's why you adopt. That's why you attempt. In that case, you already know the factor structure. You don't have to do EFA. Okay, now let's click descriptives. Let's click descriptive. Okay. Okay, I think you can't see. So this is what appears, right? Yes. So for this, just click determinants, KMO, and empty image. Okay? These are the things we want to look at. Why? Because these are the things which will tell us whether your model is meaningful and whether there is any validity issue. Okay? Later on, you will see the table. Okay? So right now, just click this one. Okay? The rest, just ignore. Okay? By the way, you will find all these steps in the manual by Ramaya and also Julie Pala. Okay? So you will find all this. Okay, especially the book by Julie Palan, she explains quite a lot. Almost every item, almost, not everything, but almost everything she explains. Okay, even though you don't click it, she will explain what it is, so that you understand why you click, you understand why you don't click. Okay, and understanding is more important than clicking. Okay, clicking you can learn from YouTube. You don't have to learn from me, alright? Or you can learn from Dr. Nishi directly, Okay, so if I teach you clicking, we should have finished in one day. Okay, everything click, 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 click. Why is this? Don't ask me. Just click. Then we finish everything in one day. Okay, but understanding is very important. Okay, click continue, please. Right. Once you click continue, you will go back to this box again, right? Now this time, can you click extraction? Extraction. Okay. When you click extraction, you will see this box, this message, right? Now, I hope you remember what I said earlier. By default, extraction method is principal components. Okay, if you click this one, you will see there are many other things. Okay, at the moment we will keep this. Okay, because we just have to learn what we can today. And now it's already 11:40. Okay, this is something useful if you want to check whether your model is fit or not. Okay, for those who use MOS, list real, M+, okay, maybe these terms sound like alien language from Jupiter to the students, but for Dr. Lishing, she knows all this. Okay, so this is a technique where you can get model fit results. But remember, this is the exploratory stage. Okay. Now, this is the one which I mentioned just now. Principal axis factor. If you use factor analysis in SPSS to run EFA, you should be using this one. The reason, okay, please read the book by Tabashnik and Fudel. Okay, please read the book by Tabashnik and Fudel because it's very statistical. Okay, it has something to do with shared variance and unique variance. Okay, so if you run EFA, by right, you should do this. But I bet, for those who use factor analysis in SPSS, 7 out of 10 maybe they will use this. Nothing wrong. Okay, so for the sake of illustration, I will just keep it this way. Okay, because whichever you choose, this one or this one, it will generate the same tables. The difference is the result. Okay, so we just explain what the results mean. Okay, it doesn't matter whether the results are good or bad. Okay, for us, we don't care at the moment. So I'll just keep it as it is. Just remember that there are several choices. Okay. Analyze. We will use correlation matrix by default. Okay, so that is why earlier I mentioned data. What is it? EFA is run based on correlation. Okay. All right. This is what I said earlier. This is the most lenient criteria. Okay. Remember, you have 10 items. You want to know how many factors are there, and these 10 items, which item should go to which factor. Okay, you have 10 items, you want to know how many factors, and you want to know which item goes into which factor. So this is one lenient criteria where you tell the software you only want results based on eigenvalues greater than 1. Okay, later on, when you see the result, you will understand why. Okay, if you want to cheat, okay, you can put like this, something lower, okay, and then you don't tell your examiner. Okay, if you want to cheat, okay, you put something like this. Okay, when you are really desperate, why? Because if you put your eigenvalue at 1, and let's say the data is really poor, your total variance explained, later on you will see, might be less than 50%. If it is less than 50%, the result is basically telling you your model is not working. Your model is explaining less than 50% what is happening in the world, the issue that you are investigating. Okay? If that is the case, your model is not a good model. Okay? That could be the end of your research. Okay? So later on you will see you want your total variance explained to be more than 50. If possible, more than 60%. How to increase the percentage? You can increase the percentage by decreasing this number. Okay? You make it more lenient in order to accommodate more data, more information. And that is how you compromise. You allow poor data to go in because of your desperateness in order to get the results that you like, so that you can show to your examiners, look, percentage 65%, wonderful, pass. But you did not report this. Okay? Now, this is something that you force the data to do what you want. Okay? You don't want to wait and see. You just tell the software, there are 10 items about FN, food and phobia. In order to make it easier, in order to make it easy for me to manage, in order to show to my examiners, my reviewers, that it looks impressive, maybe the magic number is 3. Okay, 3, magic number 1. Out of 10 variables, 3 will go to factor number 1, 3 will go to factor number 2, 4 will go to factor number 3. It looks just nice, right? 1 factor, 3 items. Second factor, 3 items. Third factor, 4 items. It looks nice. Okay, so this is what you can do to manipulate. I would not say you falsify the data, because you did not change the data. You did not change the data. What you are doing now is you do something deliberately to get some, in order to produce something more presentable, something that you want. Okay, all right. That is why one of my friends, his son is in Cambridge University studying maths. Okay. He told us, those who don't know maths study statistics. Okay, statistics are for those who do not understand mathematics. Okay, so I think this statement is quite offensive, but I think for those in pure maths, they are more into solving problems, and when they look at statistics, they know there are so many things we can abuse, we can deliberate, we can adjust, so you cannot just believe the numbers on face value. Okay? So anyway, delete this one. Let's keep this one. Okay? Now, this is another thing, remember, which I mentioned. In order to check whether your data is correlated, you need iteration process. So by default, 25. But if your data is poor, you may get an output. I can't remember what the message is. It happened to me some time ago. But basically, the output and the message tells you that the analysis cannot produce the result because of poor data. I cannot remember what is the exact message, but basically that is the meaning. So what you can do is, you can increase, okay, more, okay. 35 times not enough, so you force another 35 times until something comes up. Okay, something comes up. Again, something you manipulate, you did not change the data, but you torture the software to tell you something. Alright? So, but right now, let's keep it 35. Okay, let's keep it at 35. Click continue. Okay. Now we have to move on to the next one. Rotation. Okay, rotation. I think this Saturday, when you look at Smart PLS, then you will blame me. Why am I teaching you all this stuff? Smart PLS could have saved our life. Okay, but again, you still have to know the mechanism behind. Alright? Even if you don't use it, but if in the future when you read some articles, maybe this will help you to understand better. Okay. As I said before, many people will click this one, very nice. Nothing wrong as long as your assumption is sorry. Okay, thank you. Now you are very fast. That is very good, huh? Few days ago, I spoke for 1 minute, 2 minutes only. Okay. So anyway, so okay, can you see factor analysis rotation? Alright? So most people will click this one. Okay, so click this one. Okay? So if you click this one, what it means is the factor structure that EFA produces. Let's say there are 3 factors. These factors are not related. Okay? Now, do you think they are not related? Remember these 10 items? Remember these 10 items that you remember the 10 items that I showed you just now? The wordings are different, but they sound related, right? I don't like to try new food. I don't like to try anything new. I don't go to new restaurant. Even though the wordings are different, they are somewhat related. If that is the case, using Varimax, you already compromised the assumption. You did not meet the assumption. Okay? It's better to use Promax. Okay? Or direct or bleeding. Okay? You can read the manual by Professor Ramaya. Okay, I think I will not explain this too much. Why rotation is needed and why Promax. Okay, I can't remember. Maybe he used direct or bleeding. Okay, either one. Okay, either one. Okay. So just remember, Varimax, you assume these factors are not related. Promax, the factors are actually related. Okay? But what we hope is they are not related too much. Because if they are correlated too much, then the data, the result actually suggests these 2 variables are actually the same. Okay? For example, Dr. Hiram and Mr. Ting. Okay, Dr. Hiram works at the university. Mr. Ting is what people in Sarawak club, a club that I joined, will call me, will tell me. My roles are different, my functions are different, but these 2 persons are actually the same person. Okay? So these are not 2 persons. This is actually 1 person. Okay? So high correlation is not a good sign. Okay? Again, this may be something shocking to